or part E, right? So we want to find the instantaneous rate of change of the function. So we need to find an f of x plus h, which is going to be x plus h to the fourth power. So this would suck a little bit to multiply out, right? This would be maybe one way of doing it is x plus h squared times x plus h squared, which would then be x squared plus 2xh plus h squared times x squared plus 2xh plus h squared. And then you'd have to kind of distribute super distribution, right? X squared times f squared, x to the fourth. X squared times 2xh, 2x cubed h. X squared times h squared, x squared, h squared. And then you'd have to do the same thing with this middle term, whoops, with this middle term, and then finally with this last term, and then combine all of your like terms. This is where things like the binomial expansion theorem really help us out. So this x plus h plus 4, if you either expand or kind of know binomial expansion theorems, you'll get x to the fourth power plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth power. So when we find our limit here, we have this as our function. We're going to take that whole thing that we just found. So we have the limit as h approaches 0 of all of this here. We're going to take away f of x, which was just x to the fourth power, all over h. Again, we have a polynomial, so our f of x term should cancel out. As we've seen a bunch of times, there's an h in everything in this numerator. So I can pull out an h and be left with 4x cubed plus 6x squared h plus 4x h squared plus h cubed. This h and that h cancel, and we're just going to be left with the limit as h approaches 0 of 4x cubed plus 6x squared h, which is about to be 0, plus a 4x h squared, which is about to be 0, plus an h cubed. When I plug in 0 for every h, be careful that you're not plugging in for x. Each of these terms just go away because they're 0, and we're left with f prime of x is 4x cubed. So if I want f prime of 3, it's going to be 4 times 3 cubed. 4 times 27 is 108.